We shall have a look at the corner isolation problem. Now it is a simple classification problem in which two-dimensional input patterns are chosen from minus x1, 1 the whole square, and these patterns need to be separated into two classes. So what is the meaning of minus 1, 1 the whole square? Is nothing but we have taken a square like this. The point we have minus 1, 1, 2, 1, 1, and you have 1, minus 1 and 1, minus 1, minus 1. So basically it is a square from minus 1 to plus 1 in the x1 side, and also in the x2 side it is from minus 1 to 1. So basically, if at all I show it like this, this is x1 and x2, this square is nothing but here. So which are these points? Minus 1, 1, 1, 1, 1, minus 1, and minus 1, minus 1. So this is the square which is taken into consideration, and in this particular square what happens is that there are two different types of patterns. So there are patterns belonging to two different classes. Now which are those patterns? You can see here there are small circles which are there. These are all belonging to one particular class, and then there are crosses which are shown which are belonging to another class. So there are two different patterns. So these are the crosses. Now if at all you look at these particular patterns, what will you observe is that these crosses are mostly appearing at the corner. If at all you see here, there are how many corners for a square? There are 4 corners for a square. So along the first, this corner, this corner, this corner and this corner, you can see that there are patterns of one particular class, that is class of x's, and all the other patterns which are the zeros or the circles which are there, those are appearing somewhere in the middle. There are two classes, and these two classes have to be separated by using a neural network. Now how it will be done is that it is not a linearly separable problem. You cannot just draw one line and separate this particular two classes. It is not possible to just draw one line here and separate this particular classes, or at the most you require more than one line. So one line, a single, that is one line corresponds to a single neuron or a single perceptron. A single neuron or a single perceptron cannot separate the patterns of both these classes, and hence it is a non-linearly separable problem, meaning it cannot be separated by using a single line. So that is what is a corner isolation problem. So why it is called as a corner isolation problem, I will repeat, because the patterns of one particular class are along the corners and the patterns of the other class are along the center. It may not exactly be along the center, but rest of the square, those patterns will be there and they will not be along the corners. So now this is this corner isolation problem cannot be solved using your previous things what you have studied. So what we will be doing is that we will be using the Markant's algorithm or the tiling algorithms and neural tree algorithm. All these algorithms which are the network growing algorithms, those can be used in order to solve the corner isolation problem. Now coming to this particular thing, what we have to see is that first we shall see how we can simplify this corner isolation problem. Rather than taking so many points in the pattern space, we will be taking few limited points in the pattern space and see what happens to the corner isolation problem. So doing that, what we have got is that we have taken a few training samples from this particular corner isolation problem. So what we have seen is that this is a simplified training data which is used to design a neural network for a corner isolation problem. So there are two classes, and we have the class 1 which is made up of X, and the other class is made up of zeros or circles. So these are the two classes. So whether at these points, the patterns of class 1, that is X's, are lying along the corners. So we can see here along the corner, this is minus 1 comma 1, this is 1 comma 1, this is 1 comma minus 1, and this is minus 1 comma minus 1. So class 1 patterns are lying along the corners. And where are the other class patterns lying? Class 2, which are the circles. First of all, first circle is lying at 0 comma 0. Second circle will be lying at 1 comma 0. This one is lying at minus 1 comma 0. This one will be lying at 0 comma 1, and this one will be lying at 0 comma minus 1. So these are the patterns. Now what happens is that if at all we want to use something called as a pocket algorithm, if at all we use pocket algorithm, or if at all we use Adeline is nothing but adaptive linear network, which is similar to your Widrow-Hoff learning rule. If at all you use those techniques, what will happen is that you can get one particular line, and if at all you get a particular line, then that will not completely classify the entire all the problems from the pattern space. So what happens is that if at all we use a particular line to separate, and this line is developed using Adeline algorithm or the pocket algorithm. So if at all we take any line, and this is a line which I draw here. Now what you can see is that this line will not be able to separate all the patterns. Okay, so all the class 2 samples are on one side except for this particular sample, and all, so this side I can say is class 2, because majority of the samples are belonging to class 2, and on the other side of the line I say that it is class 1, because majority of the samples are belonging to class 1. So at this particular time I will have this particular pattern misclassified, this particular pattern misclassified, and this particular pattern misclassified. So at any time there will be at least 3 misclassifications. So now if at all I take any other line, if at all you take any other line and see, say if at all you take a line like this, and here what happens is that it is not even classifying, it is taking both the points, both the classes have equal points, and this has got equal points here, and so it is not going to do any classification as such here. So if at all you take a line here, what happens is that, yes, this is all patterns of class 1, this side all patterns of class 2, but this one is misclassified. So again 3 patterns are misclassified, as you can see. So what you can say is that if at all you use Adeline or a simple neural network